All right, y'all, let me let one more in. All right, so 9.2 deals with what we call inverse functions. So the first thing we do is we're going to show you how to find the inverse of what we call a relation. So finding the inverse of a relation. So remember, a relation was a set of ordered pairs. So I'm going to show you the general form of these. So say I got a set of ordered pairs. This is what they're considered a relation. So to find the inverse of this relation, we switch the X and Y values of each ordered pair. So doing that, your answer for the relation would be in the form of BA, DC, and FE. So all I did is I took each of these ordered pairs and switched those X's and Y's around to get the inverse relation. So let's try one of those. So we'll do two problems dealing with that kind of theory. So we're going to find the inverse of the relation. And I'll let y'all answer this. So my ordered pairs are going to be -9, 2, -7, 7, -2, 9, and 5, -5. So for that answer, MathLab will start you out with those two fancy parentheses. So y'all name off my answer. Well, I must have y'all on mute. I ain't hearing nothing.
2, -9. 7, -7. 9, -2. -5, 5.
Oh, that wasn't too bad. All right, so thinking about what we just did, let's see what y'all do to this one. We're going to find an equation of the inverse relation. So they're giving us the equation x to the third times y equals -7. Do y'all want to try that one? So y'all think, what do we do up here? All we did was what? Switch those x's and y's. So all I'm going to do is switch these x's and y's around. So that makes this a y to the third times that x equals -7. So remember, just switch the x and y. All right, y'all, let me let one in real quick. All right. All right, y'all good on those two? All right, so let me pull the chat up so I can watch it as I go. All righty, so now when you're dealing with functions, for a function to have an inverse, it's got to be what we call one-to-one. So in math, when I say one-to-one, so y'all remember back in when we was in chapter 2 dealing with functions, we said a function was a relationship in which each x had one and only one y value. Well, for a function to be one-to-one, that means also that every y value can only have one x value. So all y values can have one and only one x value. Now, for us to find x values, we're going to use what we call the horizontal line test. So I'm going to turn this over and discuss the horizontal line test. So horizontal line, I'm going to take my line and run it left to right over my graph, okay? Remember the vertical, I'm getting backwards. The vertical line test we used to tell if they were a function. We're now going to use a horizontal line test and bring it down, okay? So what this means, if a horizontal line can intersect a graph more than once, the graph is not one-to-one. Okay, so oops, I hit the camera, didn't I? My bad, y'all. I didn't put that back. So this graph right here, we're going to determine if that's one-to-one. So let me draw that on my page here. Determine if one-to-one. Because y'all, what's going to happen, if our function is one-to-one, then that means we'll be able to find a inverse function. And I'll show y'all how to do that in just a second. So my first graph, and my x-axis and my y, and they had the graph going left to right uphill. So is that graph one-to-one?
Yes.
Definitely, because look, we bring that vertical line, it only intersects that graph at one point all along this. So good job. That is definitely a yes. All right, next I'll draw a parabola. Remember, my parabola is sort of curved up each side.
No.
All right, so let me see. I gotta. Kind of respond to someone get on here. So definitely that's a no because it hits it on both sides. So that was a no. Now, I'll tell you what we do on this kind of stuff. We can restrict the domain and say, hey, for all x's greater than 0. So if we said x's were greater than 0, you just got half of that parabola. Well, if you just have half that parabola, then it would be a yes, okay? But like it is, that is definitely a no. All righty, y'all. So let's get into the gist of today. So the big thing for 9.2 is finding an inverse function. So remember, f of x is my function notation. We're now going to introduce you to f-1 of x, which is inverse function notation. Now, we don't treat that like an exponent or anything. It's just symbolism, so that when I'm done, I know that this is the inverse function of what I started with, okay? So, a few steps when finding an inverse function. So, I'll give you a function like f of x equals something. Well, with that f of x there, we really can't solve it. So my first step is I'm going to replace the f of x with a y. So instead of f of x equaling something, it'll now be y equals something. So y'all remember earlier when we were dealing with the relations, what was we doing to those?
Are you talking about the golf?
Well, when I had those little ordered pairs, right? All those ordered pairs.
Oh, yeah, swapping the numbers.
So what do we do to those? Okay, I see it now. Swap them. So that's what I'm going to do here. I'm going to switch that x and y. So instead of saying y equals something, it's now going to say x equals something. Now that we switched that x and y, we now solve for y. Now, once I solve for that y, I'm going to replace the y with my f inverse notation. So that when I'm done, it won't say y equals something, it'll say f inverse equals whatever we get, okay? So a few steps. The trickiest part is solving for the y, okay? Y'all, let's knock one of these out. So these will start at number 7 for you. So I'm going to sort of list what number I'm doing while we're going through. So it says for the following. Determine if it's 1-to-1. Then it says if 1-to-1, find the inverse. So I'm going to give y'all a little hint. All the problems after number 7 are definitely going to be 1-to-1. So you will have to find the inverse of each one of these problems, okay? For number 7, they're giving us this. F of x equals x plus 2. All right, so y'all, first thing we said we're doing to that. I'm going to replace that f of x with a y. So f of x, replace it with a y. So this is now y equals x plus 2. And that's another thing we want y'all to realize. F of x and y are definitely the same things, okay? So first step we did, replace f of x with a y. Now, my second step, it says, hey, switch that X and Y. So if I switch to X and Y, I'll have X equals Y plus 2. So there we switch X and Y. All right, now I need us to solve for the Y. So I need to get this Y all by itself over here. So I got one move basically. We're going to come in and subtract 2 from both sides so that this side gives me X minus 2. We go to the right side, all that's left now, those 2's cancel, so all that's left was my Y. And then last step, replace the Y with F -1 of X. So Math Lab will give you that part of it. They're going to write the F -1 of X for you. All you're going to do is come in and put X minus 2. Okay, so that last step, we replace Y with F -1 of X. No, they're not too bad. It's it goes back to seeing how good you are at solving equations is the main thing in here. So question on that. All righty, so let me turn over for our next. And move this back up. All right, so I'll skip 8. It's the same thing with a line. So I'm going to go to y'all's number 9. 9, we have F of X equals 5 over X plus 9. So it's definitely 1-to-1. So we're going to find that inverse. So the first thing you're going to do, replace that F of X with a Y. So now I got me an equation with a Y equal 5 over X plus 9. Next step.
Which X and Y?
All right, so we'll switch X and Y so that I get X equals 3 over Y plus 9. So now we sort of got a tricky equation to solve because that Y is in the denominator. So
3.
say again.
You just changed the 3 and the 5.
Oh, did I do that?
Yeah.
That's a 5, right? We can't do magic. We can't do magic to them. Operator error, right? All right, now, so I'm going to tell you a trick when I do to these. Basically, I'm going to flip-flop that X with that Y by plus 9 so that I get the Y plus 9 up here and the X down here. So the first thing you would do to do that, you would multiply both sides by the Y plus 9. And the reason I want to multiply both sides by Y plus 9, because if you look on the right side, those Y plus 9s cancel. So I got the Y plus 9 on the left side times the X equal to that 5. Now, remember, we're solving it for this Y. So you don't want to distribute that X and multiply that. We need to get rid of that X. So what we're going to do now is divide both sides by that X. So notice these X's cancel. Now,
Still on 9.2.
say again?
We're still on 9.2, right?
Yeah.
Okay.
So that'll give you Y plus 9 equals 5 over X. So if you notice in the long run, all I did was flip-flop those just to get the Y plus 9 up there where I could actually solve for that Y now, okay? All right, now I got one more step, get that Y by itself.
Subtracted by 9.
But I'm gonna subtract it by the 9. So over here, that gives me my y. And that 5 over x minus 9, we can't do nothing to that. So I'm just gonna leave that at 5 over x minus 9. So remember, MathLab is going to give you that f -1 of x. So all we do is put in our 5 over x minus 9. That's probably the trickiest one because it's got that variable sitting in that denominator, okay? All right, so I'm going to do 10 right back. All right, y'all, here we go. F of x equals x to the third minus 4. So definitely 1-to-1 again. And you can even graph these in your calculator, go to Y1 and graph them, and you'll see visually that they're 1-to-1. So since it's 1-to-1, I'm going to replace that f of x with a y. Then we're going to swap that x and y. So you get x equals y to the third minus 4. Y'all, let me tell you this. We're going to solve for that y, but that y is a y cubed. So in this situation, you want to get the y cubed by itself first when you're solving for it. So to get the y cubed by itself, we're going to add 4 to both sides. So that I get an x plus 4 equals y to the third. So y'all, the question is now, how can I turn a y to the third into a y? Are y'all familiar with that?
Can you divide it?
Well, I don't want to divide it. I do want to do
No.
something. I do want to do something to both sides, though.
You wanna flip it?
I didn't hear that.
You wanna flip it?
Nope. So let me show you what I'm going to do. To undo exponents, we do what we call roots, like square roots, cube roots, and all that. So what I would do to this problem is on both sides, I would take a cube root. So you're going to undo exponents with these radicals, okay? And that's what they call that little square root looking. So now, I'll tell you, the right side, when you take the cube root of a y to the third, you get a y. Question is, can you do anything to this side? And y'all are saying no, right? So my final answer, since we now solved it for the y, would be the cube root of x plus 4. So y'all, let me prove what I just did, because that's sort of tricky doing these roots. Think about this. 5 squared equals what? 25? So what's the square root of 25 equal? And that equal 5, right? So see how that radical undid what that exponent did, okay? So remember that. All right, there's only a couple more of these, and then we'll get into 3, 5. This one has f of x equals 3x squared plus 2. Then it has a comma and says x greater than or equal to 0. Now this one, they gave me this much of the answer. They gave me the square root of something over 3. what we got to figure out is what's going on top of that fraction. So they gave me that much of the answer. They're giving me a function. Now this x greater than or equal to 0, that means if you were to graph this, it would be a parabola. But since they're saying x is greater than or equal to 0, when you graph it, it's only going to come in and graph the right side of that. It's not going to graph anything over here where these x's are negative. Okay? So since they're giving me a restriction, I can now find the inverse because this half is definitely still 1 to 1. All right, so since we're going to find the inverse, we're going to switch that f of x with a y. So you're going to get y equals 3x squared plus 2. All right, next step. Let's see.
All for one?
What do y'all think? Swap them? Swap that x and y, remember, come in and switch them around. So you get x equals 3y squared plus 2. So remember, while ago when I had a y cubed, I had to get the y cubed all by itself. Since this one has a y squared, we need to get the y squared all by itself. So to do that, our first step, we're going to come in and subtract 2 from both sides. Doing that, I get an x minus 2 equals to my 3y squared. All right, before I do the square root to it, I'm going to divide both sides by 3 because you always want the y squared to be by itself and have a 1 in front. So we'll divide both sides by 3. So that'll now give me x minus 2 over 3 equals y squared. So see, we got the bottom of the fraction they gave me. That's going to be the 3 for sure. Now, to turn a y squared into a y, we take a square root of both sides. So the square root of y squared on the right side is just going to be the y. Square root of x minus 2 over 3, we cannot do anything to, so that's going to stay a square root of x minus 2 over 3, which means up here in the answer box, they gave me everything except for the top, so I would just come in and put the x minus 2 and be done. Okay? So y'all keeping up with me on these, right? Oh, let me tell someone real quick. All right, so here we go. Number 12, the last one in 9.2. F of x equals square root of x minus 3. All right, y'all, let me get another one in here. All right, so it's definitely 1 to 1. This graph would sort of be like this. If you graphed it, it would be like a gradual, slow hill, okay? So it's 1 to 1. So the first thing we're going to do, replace that f of x with a y. Then we're going to switch the X and Y. So that you now have X equals the square root of Y minus 3. All right, so here's the thing. We can't do nothing with these things under the radical. You can't add 3 to both sides or nothing like that. We got to get rid of that radical first. So if radicals undo exponents, exponents are going to undo these radicals. Now remember, since there's not a number in that little notch, you got to treat it like it's a little 2 sitting there, okay? Which means to undo square roots, we raise them to the second power. So I'm going to come in and square both sides. So the left side, x squared, x times x is just the x squared. But when you square this square root, it gets rid of the square root, and all that's left is the y minus 3. All right, so my last step now to get that y by itself, I'm going to come in on both sides and add 3. So we get a x squared plus 3 equal to our y. And remember, Math Lab's going to have f negative 1 of x for us for our y. So we just come in and put our x squared plus 3. So y'all, they're not too bad. Just follow the steps, replace the f of x, switch stuff, and then turn the y back into a f negative 1. Solving them is the tricky part, okay? All right, so now we're about to do what y'all been waiting on. 3.5. So did y'all have questions out of that 9-2? Y'all good to go then. All right, so here we go, 3.5. Systems of equations. So what I'm going to do is I'm going to start out with a 2-variable system of equations, and then we'll work our way into the 3-variable equations. So we're going to sort of start out small and get big. So I'm going to show you an example. They want me to solve by elimination. Now, the system they're giving us is a 6x plus 5y equals negative 33. Then they're giving me 3x minus 5y equals a negative 39. Now, we're going to get rid of variables by adding these 2 equations together. Now, if I'm not able to get rid of a variable by adding these together, I can change either or both of these equations to make that happen. So on this one, first thing I want to do is pick a variable to eliminate. Well, y'all look at that. You got X's and you got Y's. What do y'all think is easiest to eliminate by adding?
X's.
5.
Okay, I heard X's and Y's. So let me show you this. Look at this. If you add 6x's to 3x's, that's giving me 9x's, right? But if I add that
Yeah.
5y to that negative 5y, they cancel, which means they are now eliminated. So we're going to eliminate those y's first, okay? Because to do the y's, I don't have to change nothing. If I wanted to do the x's, well, I got a positive 6x and a 3. If this is the 6x I kept, I would have to somehow turn this 3 into a negative 6. So to do that, I would have to multiply that whole row by a negative 2 to make that happen. So since the y is already canceled, let's just add this and get that. So that gives me what, 9x's. The y's cancel. Negative 33 and negative 39 is a negative 72 when we add. So now that I've eliminated the variable, I'm down to a single variable. So now I'm going to solve for the x variable. And that's all that's left. And y'all can do this in one step, right?
Divide by 9.
Divide by that 9. So we
Negative
now
8.
know x is, oh, what's that, a negative,
Negative 8.
negative 8. So now that we know x is negative 8, we need to figure out what the y variable is going to equal. So our next step, plug negative 8 in for x on either of the original equations. So y'all, which one's easier? 6x plus 5y equals negative 33. 3x minus 5y equals negative 39. Which one y'all want me
First
to
one.
use? The first one? So that's going to give me 6 times x, which we said was negative 8, plus 5y is going to equal that negative 33. So I would probably multiply this and make this a number first. 6 times negative 8 gives me negative 48, plus my 5y equals that negative 33. All right, next I need to get the 5y by itself.
Add 48.
Add 48. So now you got 5y, that's a positive. Let's see, 48 minus 33.
15.
Gives me a nice little 15. So now solve this for the y. One more step.
Divide 5.
So that I now know y equals 3. Now, y'all, here's the thing on these. When you write the answers, these answers got to be put in like ordered pairs or ordered triples. So this one only had 2 variables. So it's going to be an ordered pair, but you got to get them in the right order. You got to have your x first and then your y. So since my x was what, negative 8, I would put my negative 8 and then my 3. Remember, put them in parentheses so that it looks like an ordered pair. So that wasn't too bad, was it?
Not too bad.
So let's do one where we might have to do a little changing. So same thing here. This one's going to say solve by elimination. But you know, I'm probably not going to give you something like that 5 and negative 5y on this one, okay? So we got 8x minus 9y equals 32.5. This one has 7y minus 2x equals a negative 10.5. Now I'm going to tell y'all something on this one. There's one thing I need to do before I figure out what variable I'm going to eliminate.
Is it the inverse or switch?
So I think what, are you looking at that second equation? It's sort of out of order, ain't it?
Yeah.
Yeah, so let's rearrange this order. So the first one I'm going to keep as the 8x minus 9y equals 32.5. This one will be a negative 2x plus 7y equals a negative 10.5. So we need our x's in one column, the y's in their column, all the answers in their column, okay? So make sure you got them in order from the x's, the y's, and whatever else we use.
I have a quick question.
Yeah, I hear you.
This has nothing to do with the inverse you just did.
Uh-huh. No, this
doesn't?
is all, this is 3.5, a new, we're getting into actual solving these systems of equations.
Okay, okay.
Now, if you notice this, our first thing is pick a variable to eliminate.
X's. Well, can we just do Y's this time?
Do it now?
Can we do Y's this time since we already did X's on the first one?
Well, I'm not picking just what a letter is. I'm picking what's the easiest to get rid of. And I'll tell you what, Y's are harder to get rid of than the X's on this one.
Why?
Well, because if you add a -9 and 7, you don't get rid of nothing, right?
Yeah.
So we would have to find the smallest number that 9 and 7 both go into to change this into. So that would probably be 63. So you would have to multiply this whole row by 7 to make that a -63. Multiply this whole row by 9 to make that a +63. So we would have to change both of these equations in order to eliminate that y. But look at these x's. You got an 8 here and a -2. Would I have to change both of these rows? Can't I multiply this -2 by something that would give me maybe a -8? And then that -8, when you add to that 8, would eliminate those x's, right? So y'all watch what I'm going to do. I'm going to eliminate the x. To eliminate the x, I got to multiply the second equation by 4. So we're multiplying this whole row here by 4. So notice, I didn't change the top one, right? So the top one's going to stay 8x minus 9y equals 32.5. We are changing the second equation. So if you multiply by 4, 4 times -2 gives me a -8x. 4 times 7 gives me a 28y. 4 times -10.5. Oh, let me calculate that. What's that? 4
Oh,
times
why did you
neg-
put it in the parentheses?
You want now?
Why did you put it in the parentheses?
Right here. That way you would know to multiply that 4 by everything in that row.
Oh, okay.
Okay. So multiplying this 4 times -10.5 gave me a -42. Yeah. Equations are like this. If I multiply one thing in that equation by a 4, I got to do every single thing in that equation, okay? But did it
So
work? Did it work? 8x, -8x?
Mm-hmm.
They're gone. -9 and 28 is going to give you 19y. And then let's see, we got what? -42 plus 32.5. That gives me a -9.5. Right now, solve for y.
Divide by 19.
So let's see, if we do -9.5, divide that by that 19, I get a -0.5. Now in MATLAB, you can do -0.5, or you can even do -0.5. The 0 is mainly just a placeholder for this one. But guess what? Now that I know what the y is, I'm going to back substitute. The -0.5 for the y in either equation. And it's got to be those original equations. So I can do the 8x minus 9y is 32.5, or we can plug it into the 7y minus 2x equals negative 10.5. I'll probably just do that top one. So that gave me 8x minus 9 times the y, which was a negative 0.5. All that's going to equal 32.5. All right, y'all. So first I'm going to multiply. That's going to give me a positive because I got a negative times a negative. So negative 0.5 times negative 9 will give me a 4.5. That's going to equal 32.5. Ooh, decimals are fun, right? 32.5, let's subtract 4.5 from both sides. So that 8x is equal to what, 28? And then divide by
8.
8, right? There you go. So x, I think, is equal to 3.5. Now, so I'm going to do minus fractions, 3.5 and then a negative 0.5. But if you work it as fractions, MathLab will take 7/2 and a negative 1/2. Okay, MathLab takes it either way. So y'all, that was tricky, right? So let me get into the big boards. And after I do this one, I'll show you how to do these on your nice calculator, okay? And we can do the ones I just did on the calculator, but I want to show you why you want to appreciate that calculator. All right, so let's get our paper ready. We are now going to solve a 3-variable system. So solve this system. I got an x plus y plus z equals 3. I got a 2x plus 5y plus 2z equals 15. And then I got a negative x plus 9y minus 3z equals 29. Now, since I got so many rows, I'm going to call this row 1, equation 2, equation 3. So guess what? First thing, pick a variable to eliminate. So how about this? Since I did X's a while ago, how about I do Z's this time? Although the X's are easier, do y'all want me to do Z's or y'all just want me to do the easy way?
Keep it easy. Keep it easy.
Yeah, they're the
Okay.
easy ones.
Okay, because right off the bat, if I take row 1 and row 3 and add that, those X's will cancel, right? Because you got a positive X and a negative X. So my first thing I'm going to do, I'm going to add row 1 and row 3. So row 1 was x plus y plus z equals 3. Row 3 was negative x plus 9y minus 3z equals 29. So let's add them together. The x's cancel. 1y and 9y give you 10y. 1z minus 3z gives you negative 2z. And then 3 plus 29 give you 32. So that is going to be our equation 4. So over here, my equation 4 is going to be 10y minus 2z equals 32. All right, but guess what? When you got 3 variables, it's twice the work. I now have to use the middle row and add to one of these 2 rows and get rid of that x again.
Hold on, say it all over again, because I didn't understand.
Okay, so I turn, what you got to do now, since we used row 1 and row 3 to get rid of the x's, we now have to use the row we didn't use, which is row 2. We need to take row 2 and do something to one of these 2 rows so that I can eliminate that x again. So let me work y'all through it. So what I'm going to do, since that's a positive 2x, I'm going to multiply the 3rd row by 2. So I'm going to multiply row 3 by 2 and then add to row 2. So you got to do this twice because you got to use all 3 equations, okay? So pick any 2 the first time. After you do that, you got to use the other equation with either one of those. But notice, 2 didn't cancel with a -1 or a 1. So I definitely got to change one of these rows, okay? So we're going to come in here. We're going to roll this whole row by 2. So multiplying row 3 by 2, 2 times -1 gives you a -2x. 2 times 9 will give you 18y. 2 times -3 gives you -6z. And then 2 times 29 gives you 58. That was row 3 getting multiplied by 2. Add that to row 2 now, which was 2x plus 5y plus 2z equals 15. When we add them together, we'll have our equation 5. So y'all look, the x's cancel. 18 and 5 give you 23y. -6 and 2 give you -4z. And then let's see, 58 and 15 give you 73. So row 5 is now 23y minus 4z equals 73. So y'all, my only goal at first was to turn a system of 3 variables into a system of 2 variables. So we done did 2 of these systems of 2 variables. So what do we want to eliminate here? So I'm hoping y'all are saying z's on this one. Because to eliminate the z, I got a -4 and a -2. Can I multiply this -2 by a -2 and make that a +4? And then that +4 would cancel with that -4. If you change the y's, you'd have to multiply this by 23 to make that a 230. This one by -210 to make that a -230. So the y's are a lot harder to cancel, okay? So to eliminate the z, I'm going to multiply row 4 by -2 and then add to row 5. So if we take this row, multiply by -2, you'll get a -20y plus 4z equals a -64. Bring down row 5, which was 23y minus 4z equals 73. See, it was easier to do the z's on that one because they're now going to cancel. So -20 and 23y give you 3y. -64 and 73 give you 9. So now solve that for the y. So that gives me what? One move, divide both them by 3.
About 3. Y
You
is
know,
3.
now I get y equals 3. So y'all, here's the trick. Let me pull this down. Since I now know that y equals 3, I'm going to take that y equals 3 and back substitute into either, I'm going to back substitute into equation 4 or 5. Right? Remember, 4 and 5 are right here, these two little equations. I'm going to pick one of them so that I can find out what the z equals. Then I know the y and the z. I'm going to plug them into one of these over here and get the x. So you got to do the back substituting twice on these, okay? So here I'm going to make a y equals 3. I'll just use the top one. So I got 10 times 3 minus 2z equals 32. Solving that, that's going to be 30 minus 2z equals 32. I'm going to subtract 30 from both sides. -2z equals 2. And then y'all, I'm going to divide by -2. So that I now know z is a -1. Now that I know z is -1 and y is 3, I'm going to plug them back into the first equation I had up here, because that looks the easiest. So we're now going to back substitute again. So let me pull back up. Need more paper. So I'm going to back substitute. Z equals -1. Y equals 3 into one of the 3 original equations. So I'm going to use x plus y plus z equals 3. So I don't know x. I know y is 3. Z is -1. That's all going to equal 3. So y'all watch this. 3 -1, that's going to give you x plus 2 equals 3. My final step to get the x, subtract 2 from both sides, and I get x is 1. So that answer has to be an ordered triple because we had 3 variables. So let's see, x was 1, y was 3, z was -1.
This can all be put in the calculator, right?
Now watch the calculator. So
That was entirely too much.
not too bad when you got 2 variables. When you got 3 or more, whoo, this is hairy. All right, so I got my problem I'm going to do. I'm going to do the same problem on the calculator, okay? So my calculator, you should be able to see on the left side all the buttons I'm pushing, okay? All right, so let me move this chat over a little bit. Whoops. All righty. So y'all see my calculator screen?
Yeah.
Now on
Yes.
the left side, does it say key press history like mine? All right. So the first thing we got to do is put those numbers into what we call a matrix. So to get to the matrix, you're going to hit the second button and then the X -1 button. If you notice the X -1 button right above it, it says matrix. So we're going to put these into the matrix. Now, You should be on this screen. So what we need to do, we're going to edit a matrix. So I'm going to arrow right until edit is highlighted. And then I'm going to come down and hit enter. Now, for the matrix, we need to tell it how many rows we got and how many columns we got. So y'all, on the problem I just did, I had 3 rows of equations. So I would put a 3 and enter. And then we had 4 columns. We had an X column, a Y column, a Z column, and the answer column. So we had 4 columns. So y'all should be seeing something similar to me. Matrix 3 by 4. Now when I hit enter on that column, it brings up all the places where I'm about to put numbers. Now, this first column will be our X's. Second column will be where we put the Y's and so on. So it's going to start with the first equation. My equation, I had 1x, so I would do 1 enter. Now, we don't do variables, we just do the numbers. If there's not a number in front of that variable, it is definitely a 1. I had 1y, so I would do 1 enter for the y. I had 1z, so I would do 1 enter for the z. And then the first equation had an answer of 3, so I do 3 and enter. And it goes down to the second row of equations. Well, my second row, I had a 2x, so I would do 2 enter. 5y, so I would do 5 enter. 2z, so I would do 2 enter. And then it had an answer of 15, so 15 enter. It goes down to the bottom row. On my bottom row, I had a negative x, so that's a -1. Use the negative in parentheses. So -1, enter. I had a 9y, so that would be 9, enter. I had a -3z, so -3, enter. And then it had an answer of 29. So you do 29, enter. Make sure that 29 pops up on the screen. So we just put all of our numbers for our equations into this calculator. So now we're going to quit this screen by hitting second. And right next to the second, it says mode. Hit mode. And if you notice right above mode, whoops, let me go back. Right above mode, it says quit in blue, okay? Now, our matrix is in our calculator. Now we got to make it do the work. So we're going to hit second x -1, because this is where we're going to find our matrix operations. So to do the operations, you want to arrow right and highlight that math column. Once math is highlighted, arrow down until you find RREF. Notice right above it is the REF. We don't want that, and we want to reduce it all the way. So we're going to go to RREF, highlight that, and hit enter. And it brings that to your screen. Now, it's going to reduce the matrix I just made. So we now have to go get that matrix. That matrix is in second x -1. So for me, I used a while ago. So see, it's saying I got a 3 by 4 matrix in A. So since A is highlighted on the 1, I'm just going to hit enter. And now on my screen, it's telling me that it's going to reduce this row to the answers for matrix A that I just made. I hit enter. Now, you got a 1 in the first column. Where the X's go, if you go all the way right, that tells me X is 1. Second row, you got a 1 in the second column. That was the Y column. That's telling me Y equals 3 all the way right. And in the last row, you got a 1 in the Z column. So that means Z equals -1. So the top one in the right corner is the X, the 3 under it is the Y, the -1 under that is the Z. So let me see what my chat says. Not too bad. No, so y'all want to do another example with it real quick? Before I
Yes,
make y'all-
please. How many questions is on the thing? Cause
On the what?
how many questions is on the homework?
Oh, like 11.
Okay.
So, but it had a bunch of them in the beginning. We're doing the 2 by 3 equations,
Uh-huh.
and then other stuff that wasn't that bad.
Okay.
So the reason we want our calculator is for, I'm going to do, let me show y'all what I'm doing real quick. And let me clear that screen so I can start over clear. All right, so let me go back to the camera real quick. So I'm going to do this problem right here. 4x plus 3y plus z equals 27. X minus 3y plus 2z equals 6. 11x minus 2y plus 3z equals 45. So I'm going to go to my calculator and enter all this and then show y'all what to do. So let's go. So calculator screen. All right, so to start out, I'm going to go to second, x -1 to get my matrix. Now, I'm not going to arrow down to B, C, D, or whatever. I'm still going to use matrix A. So since I'm going to use matrix A still, I'm just going to go over to edit and hit enter. So it's already got 3 by 4. So just hit enter twice and go through that part. Now we'll say this, if you use this calculator on those problems I did in the very beginning of this with the 2 by 3 matrices, since you only had 2 equations, those would be 2 by 3 when you start this, okay? All right, so I said I had a 4 for my X, so I'm gonna go 4 enter. And it'll start changing them numbers to what I need. I need 3 enter. I had 1 Z, so that'd be 1 enter. And then that equaled 27. So 27 enter. Whoops, I must have went back. Let me go back. So that was a 1. I didn't get my 1, I don't think. So 1 enter. And then 27. So did y'all say I messed up, but I could arrow back, okay? So you can use the arrow back button to go to one that was previously if you did mess up a number. My second row was 1x, so that'd be 1 enter. Minus 3y, so that'd be -3, enter. Plus 2z, so 2 enter. And then the answer on that row was 6, enter. So the row 3, I had 11 x's. Enter. -2y, so -2. Enter. 3z, so that'd be 3. Enter. And then 45 was the answer for that row. So do 45 and enter. So make sure it changes it on your screen for you. A lot of people forget to hit enter on that last number and it messes up their answers. So remember, I now have the matrix in the calculator, so I'm going to hit second mode to quit. So second mode to quit that screen. So now calculator thinks that I just put in my matrix A. It's all stored in there. So let's go get the operation we need to do. So hit second, x -1, arrow right to math. Once you're in the math column, arrow down and find me RREF and hit enter. So remember that brought the reduced row onto the screen. Now we go get our matrix by hitting second and matrix. Ooh, I see an answer. Let's see if we're right. So grab matrix A, which is already highlighted. So all I need to do is hit enter. 336, good job. Makes you feel good when you can do that. All right, so you'll have this video to look at for doing this on a calculator. So let me go back and do a two variable equation. So for my two variable, so let me clear everything. So y'all, for my two variable, I'm going to do this one right here. 11x plus 2y equals negative 13. 2x minus y equals negative 1. So if I go to my calculator, notice that was two variables and two equations. So when I go to my second matrix, I'm still going to go right to edit. But this time, watch out, when I hit enter, since there's only two variables, this one's going to be a 2 enter by 3 rows enter. I mean, 2 rows by 3 columns. Woo. Now notice on the screen, it gave me 6 numbers to put in, and that's all I got. So my first row was 11 x's, so that'd be 11 enter. We had 2 y's, so that'd be 2 enter. We had negative 13 for that answer. My second row, I had 2 x's, so 2 enter. Minus y, so that'd be minus 1 enter. And then negative 1 was that answer, so negative 1 enter. Our matrix is in, so now we can hit second mode to quit. So you had a blank screen. So now you need to do the operation. So notice you do the second x negative 1 pretty much 3 times in here. Arrow right so we can edit. And also notice it's now saying I got a 2 by 3 matrix, right? So I'm about to see if you're right on this one. So let's see if she's right. Let's go down to RREF. Because you got what? Negative 1, negative 1. That sounds funny, don't it? All right, go back to second x negative 1, get the matrix, which was A, hit enter. So let's see. I hit enter. There you go. Negative 1. In the right corner is my x, negative 1. In the bottom is my y. Good job. Now remember, put these in parentheses when you put these in MATLAB, okay?
So I could do all the homework on the calculator, right?
Pretty much for 3.5.
Okay.
Now, it will have questions like what the answers look like. So remember, when you got 3 variables, the equation is going to be X, Y, Z, ordered triple, okay? And then remember, all the equations are like all the letters on the left side in order equal to the number, okay? So they'll just ask you little general knowledge questions, but there's only like 2 of those. So rest of them, punch them in the calculator. But remember, on the one where I got the 2 variables, one of those problems, they're going to be out of order. So you got to put them in order before you put them in that calculator, okay? X has got to be the first column, Y is in the second column, and then those answers.
So aren't they already in the last column? Aren't they already in order? So when we go to math,
Well,
just put them in the parentheses.
Well, when you solve them, you'll have them in the right order, but let me show you what I'm talking about. Remember, I did a problem a while ago, like this number 3 here. This 7y negative 2x's, those were out of order. So if you put this in the calculator, you got to make them in the right order. Okay. Once you get the numbers in the right order, in my calculator, I would punch 8 enter, negative 9 enter, 32.5 enter. Next row, negative 2 enter, 7 enter, negative 10.5. That's the only problem number 3 that you got to worry about, the order on these problems, okay? Everything else we're doing here, when you get to all these, they're all going to be in order. X, Y's, and Z's will be good. So go to calculator, punch in your numbers, and get your answers.
Okay.
Okay. All right, so here's the little questions I was talking about. Which one's an example of a linear equation in 3 variables? A, B, C, or D?
You said a linear equation, isn't that gonna be D?
It's going to be D.
Okay.
This one says, which of the following is a solution of a linear equation in 3 variables? What you going with that?
I think, is it C?
It is C. So watch out, because D looks like
Oh,
it.
wait, why is it C?
It was C. But
Why
D
is
has
C?
funny, remember, C don't have the right parentheses on
Oh.
D, okay? So that's why it wasn't D, but C was right. You got to have those curvy parentheses, okay? All right, y'all, so go enjoy 3.6 we got coming up next class. It's doing the same thing with the 3 variables. So it's just using word problems, okay? So for 3.6, we figure out the word problems, what they're telling us, and then we punch them on our calculators and get them answers. But I'll still do some more by hand just to get y'all good at that also.
Okay, are we good to leave now?
Yeah, I don't have nothing else, so I will see y'all Thursday night and practice them calculators, okay? And then